Lesson 34, uniform motion problems of the type D1 plus K equals D2. Let's start by taking out our formula sheets. And if you haven't already put this info in from lesson 29, you can go ahead and stop the video and enter those in. Those were the sum of two distances equals a constant, and we had 3 different modes. Today, we're going to discuss these next 2 problems for uniform motion. And they're both going to start with the first distance, okay, plus a constant equals the second distance. My first scenario here, my first mode would be something like person 1 gets within a distance k of person 2. Okay, so somebody gets a, not a head start, that's the next one. Person 1 gets within a certain distance, okay? Not catching them, but gets within a certain distance. All right, and the second one is person 1 has a head start. So when person 2 begins, person 1 is already k miles away, or kilometers, or whatever the case might be. Okay, already a certain distance away. So this is for a head start. And both of these formulas for distance, we can always substitute in rate times time, because rate times time is distance. So we'll do 2 examples today, one for each mode. Example 1. When the sheriff began his pursuit, Robin Hood was already 7 miles out of Nottingham. If the sheriff traveled at 6 miles per hour while Robin Hood's rate was 2.5 miles per hour, how long did it take to get the sheriff to catch up? All right, so here we have the sheriff. He begins his pursuit. Okay, so he's going to begin. Let's draw a beginning line. He begins here. He begins his pursuit. And at that time, so he's going to keep going. At that time, where's Robin Hood? Robin Hood is already 7 miles out of Nottingham. So this is our head start. Okay, so he's already here. So we're going to indicate the head start by a dashed line. Okay, so this blue dot, this is where Robin Hood is at the same time when the sheriff begins, indicated by this bottom blue dot. Okay, so think of it as there's a timer on the sheriff's wrist. Okay, he's got a watch. He looks at his timer, and the start time for him is here. Okay, and at the same time, Robin Hood is already 7 miles away. Okay, so we're going to write 7. And our goal is to find out how long did it take the sheriff to catch up. So here's Robin Hood. Remember, he's still going about his merry way. So this is D sub R, distance Robin. And the sheriff, we need to keep drawing his line because he's eventually going to catch up. All right, so he's going to catch him right here. Stop the timer. Okay, so the time ends here. So keep that in mind. All right, so let's start writing our formula here. We've got 7 plus Robin Hood's distance. What does that equal? 7 plus Robin Hood's distance from start time to end time equals the sheriff's distance. We're going to substitute in rate times time for each distance. Because distance is rate times time, we'll subscript R for Robin, S for sheriff. All right, what do we know? Do we know Robin Hood's rate? Robin Hood's rate is 2.5 miles per hour. Okay, do we know Robin Hood's time? Robin Hood's time, well, let's see. Let's talk about this. The time that we started recording time, okay, was indicated by these blue dots. Okay, end time is indicated by the red dots. So I'm going to submit to you that they traveled the same amount of time. We're not taking into consideration how long it took Robin Hood to go that 7 initial miles. Okay, all we know is that it said when the sheriff began his pursuit, Robin Hood was here. So he looks at his timer, it's the same time, okay, from beginning to end. So we could say something like this: time Robin Hood's time from start to finish equals sheriff's time start to finish. So you can either substitute one for the other, or you could just drop the subscripts altogether and just call it T, single T with no subscripts for time. All right, Robin Hood's rate. This is sheriff's rate after the equal sign. How fast was the sheriff going? Looks like 6 miles per hour. Okay, and then again, we're going to substitute TS with just T, because again, our times are the same in this case. So we're going to subtract, we're going to move the 2.5 T to the other side. Change signs, and we have 7 equals 3.5 T. Dividing both sides by 3.5, we have T equals 2. All right, so we need units. Our time units here are in hours. So it took the sheriff 2 hours to catch up to Robin Hood. Example 2, we have Mary Jane and Spider-Man. Mary Jane began the journey at 6 a.m. at 50 kilometers per hour. Spider-Man began to chase her at 10 a.m. at 60 kilometers per hour. What time was it when Spider-Man got within 40 kilometers of Mary Jane? Our key phrase here is got within a certain distance. So we know we have distance 1 plus K equals distance 2 type of setup. Mary Jane began the journey at 6 a.m. Here she is. Move this down a little bit. Get a pen. Sorry about that. Okay, 6 a.m. and here she goes. Okay, she is now here. Spider-Man begins to chase her at 10 a.m. Okay, is he starting from the same place? He's starting from the same place, yes, but 4 hours later. So this is 10 a.m. Does he catch her? He does not quite catch her. Well, he might eventually, but when we look at our watch, he's within 40 kilometers of Mary Jane. So he is on the pursuit. He's on his way. So he's right here. We want to know when he's within 40 kilometers. So really, Spider-Man's ending here. Okay, and he's still 40 miles away. Okay, so this is Mary Jane's distance for her rate times time, and this is Spider-Man's distance. Spider-Man's RT rate times time. So let's set this up. We've got D sub m, Mary Jane's distance from beginning to end. That's the same as Spider-Man's distance plus a little more, right? Plus 40. All right, let's subscript rate times time, mm for Mary Jane. And as for Spider-Man, here we go. What do we know? Do we know Mary Jane's rate? We do, 50 kilometers per hour. Do we know Mary Jane's time? So we know something about her time. We know that she started at 6 a.m., okay, and her rate times time stops here, right? Okay, so from here to here, we got to figure that out. Let's compare that to Spider-Man. We know Spider-Man started at 10 a.m., and we start calculating his rate times time until here. So right here where the red dots are at, we stopped, we looked at our watch, and it was the same time. So at this same time, he's 40 kilometers out. So all we can say is that Mary Jane's time was basically 4 hours longer, right? Because she has been traveling 4 hours longer, starting at 6 a.m. So take Spider-Man's time and add 4. And let's substitute. All right, after the equal sign, rate Spider-Man. Do we know how fast Spider-Man was going? Yes, we do. 60 kph. And T sub s, let's just leave that as is, because we already have a T sub s in the equation, so that's good. We want to have one variable to solve for at a time. All right, looks like we have to distribute here, so let's do some algebra. We have 50 TS plus 50 times 4, 200, copy down the right side. All right, looks like we should put our T's on the right. So we're going to move the 50 TS from the left to the right, giving us 10 TS, and we're going to move our constant from the right to the left. So I'm changing sides, changing signs. 160. All right, what would I multiply 10 by to get 160? 16. All right, so our time units are in hours. So it took 16 hours until Spider-Man was within 40 miles per hour. But check the question. Check the question, please. What are we supposed to solve for? What time was it? What time was it? Not how long did it take Spider-Man to get within 40 kilometers, but what time was it? We got to do a little bit more work here then. Okay, so 16 hours is T sub S. That's Spider-Man's time. So Spider-Man's time, here it is. He started at 10 a.m., so we have to add 16 hours to that to find out what time. It took him 16 hours. He started at 10. All right, so if he goes 12 hours, right, he's at 10 p.m., and then he's got to go 4 more hours later. So 10 p.m., 11, 12, 1, 2. We are at 2 a.m. in the morning. Okay, at 2 a.m., Spider-Man caught Mary Jane. Sorry, he didn't catch her. He was within 40 kilometers. All right, so that's uniform motion of type D1 plus K equals D2.